You've got a broad background of different experiences, and one thing that maybe we could start talking about is maybe some of your experiences working with wind turbines. All right, thanks for tuning in. We're glad to have you guys here with us tonight on the ProfitDig Construction Show. We've got a special guest with us here tonight. It's one of my old friends, Seth Williams.
You got me, Fro.
We used to call him Big Seth. He called me Fro. That was kind of my nickname. Yeah, Fro. Yeah. I don't hear that name much anymore. You probably still hear Big Seth every now and then.
Every now and then, yeah. When I'm around Dixon, that's I get somebody and I'm just like, oh yeah.
Yep. Got those legacy nicknames. But yeah, we're super excited to have you here with us. I know you've got a broad background of different experiences. And one thing that maybe we could start talking about is maybe some of your experiences working with wind turbines.
Yeah, for sure. I started working on wind turbines in 2014. I went to this renewable energy tech school in Denver for 2 years, and then they put me on. Used to work with Ethos Distributed Solutions. I don't even know if they're around anymore, but we did all renewables, solar, wind, and then we also built did telecom towers and some telecom work. So we had government contracts for military bases because they have to have a percentage of renewables, but it's not enough to back then it wasn't enough to keep the techs on. I'm sure the military trains people now, and that was right when all that stuff really started picking up and working and doing that stuff. So a lot of the bigger ones, the bigger wind farms and stuff, like when you're going through Kansas, the farms keep techs and keep people on staff there because they are big enough when they've got 20 to 30 or 50 or 100, and they're climbing every day. But out west, I know a lot of farmers were using them. We did with some 250 kVs and some other to help push water and to run pumps and stuff where they push water. Out there they'd have big 450 blocks next to each other running, power. But some of them would have, these wind turbine stuff that they were getting that they had gotten from government stuff back then, but they couldn't afford to have a tech and people to work on them. So we would go out once a year or however often and service stuff like
maintenance.
Yeah, literally in the middle of nowhere.
Yeah, So how much of that maintenance was ground level and how much of it was at higher altitude?
So when we were doing the bigger ones, you would have always somebody has to go up. But as soon as you walk in, there's a PLC system that basically you shut down and do safety protocols. And then as somebody's climbing, when they get to the top, it's mostly looking for gearboxes and stuff like that, because most of everything electronics at the bottom, most of your sensors, anything is only going to be at the top. So I used to just run the check program. It would check, make sure all the sensors, everything's running fine. So we always worked in pairs. But no matter what, with those checks, you just send somebody up, but not always you go out on the nacelle and actually look, for damage or stuff. We would only do that once every other year or something with some of the bigger ones, but now they do it with drones. Back then, they do it all with drones now. So any of those checks and stuff that they do, it's just easier. But this was, and this was even 10 years ago. It's crazy.
Well, drone technology has really come a long ways just in the past decade.
A lot.
It's interesting, the kind of work that I do, we do predictive analytics for failure modes. And one of those different types of assets is motor monitoring. And we use electric current signature analysis. So, obviously you can send a drone up to do a visual inspection. But what's interesting is if you can get some really high frequency current transformers to monitor the current at the ground level, that same electrical signal is going all the way up. right? And so if you know what to look for, and it's not like hand math anymore. It's all computer oriented, but it's based on fast Fourier transformers and differential equations. But the idea is that you can take the revolutions of the wind, or in this case, the turbine, or just any motor as it spins. You create some type of current signature, right? Over time. But it's hard to look at that as a human and really see what that really means. So what you do is you take it and you convert something that goes over time to the frequency domain. And by doing that, you can perform something called spectral analysis.
Right.
And from within spectral analysis, you can determine that, I bet we've got a bearing that is failing here. Or
you see it going down, you see the wave as it's going.
Well, it's not even the waveform, it's by looking at the frequency view of it, and you can see distinct patterns in how it should be operating.
I got you.
Versus analyzing it. And if you don't know what you're looking for, it can be difficult, but an expert can look at this and see that, this frequency should have a magnitude at here based on the application.
But it's a little bit out.
And if you watch that trend over time,
and it gets worse.
You can say, okay, something's wrong here.
It's like driving your car every day, and all of a sudden you're like, man, I got a little bigger wobble today.
Yeah, it's the same thing. But ideally, what's interesting is, you can use like vibration analysis, which is, it's good to do some type of vibration analysis, but it's also kind of crude. When you're looking at the electrical signal
itself, and
always precise. You can predict 6 months, 12 months in advance before that thing fails and schedule downtime appropriately.
Yeah, because it's always going to run that same voltage through there, no matter what, unless it's something that a little bit off every time. Damn, I didn't know that.
I've got a question about the turbines.
Yeah.
It may be a dumb question, I don't know, but I've always wondered. When turbines are turning, I know they're generating current.
Correct.
Is that all the current that they have, or do they have like a battery substation that they keep charged?
So with the bigger, both. So when you go and you see like bigger wind farms, as you know, there's only so much power that you can put back on the grid at one time. So
you overload the grid. Right?
Exactly. So there's no real power storage. It's like TVA doesn't store probably a lot of power. It's just those turbines got to turn to create. So a lot of times, like that's why they build such a big farm, because say you got wind on this side over here, there's if you're at 100 miles difference or 50 miles difference, wind might be better over here this day and not over here. Right. So it's putting back as much as it's possibly able to whichever grid. I think the United States has 4 grids. 3. Yeah.
Texas, and then there's like an east and west.
Yeah, and that's like one of the only reasons why Texas could actually succeed is because they're seriously, like, and that's a real thing.
Despite that situation that happened, like that perfect storm a year or two ago, they actually have like the nicest grid in the U.S. Far better maintained.
So I worked on a bunch of stuff that was up in the Panhandle, Oklahoma, like southern Colorado, in that like area, because the main junction is in New Mexico. You know what I'm talking about? There's one big, the U.S. has one large grid where all 3 come together, and I think it's in New Mexico, but it's huge. It's like, 400 miles square, just nothing.
Just massive substation.
But there's only so much that they can put back on at a time. So sometimes when people drive by and they're like, well, why are some turning and some ain't? And it's because they can only put so much back at a time.
So you can lock them out to where.
And what they do is they have a braking system in them, and like where you can there's actually a big thing, push in and twist it down so it locks it into place, so that way if you ever have to go out, you have safety.
We don't want to spin it on you while you're up there.
But what they do is they actually just pivot it to go to a 0 degree, so that way they don't spin. And that's when I would come in, that's the first thing I would do, because it takes a few minutes for, if it's spinning, for when it goes to go. Exactly. So by the time he's up there, it's probably in place. And then what you do is, there's a hatch, and if your hatch isn't turned up and it's not oriented correctly, we have a bump system. So you'd be like, bump it, bump, and just you hear this whole thing go, like the whole thing, and just enough to where we could get it spun around, and then he could put the safety lock in. So that way, if while you're up there, you don't want everything, because it's some of the gearboxes are twice the size of this table. You know, you've seen the huge, y'all seen the huge ones. Like, it's crazy. So
I've seen them in Central America, you know, and I haven't really seen it in the U.S., but I've been to Central America a couple of times. And I mean, like hillsides, just full of them. I mean, just everywhere.
And they do. And to find out where to put all of them, they do a 10-year study. Well, they do a 5, a 7, and a 10. But they're called med stations, and basically it's just a little bitty box that they set out in different areas to figure out exactly how much
over that period
of time. Exactly. So that, because I mean, if you're breaking ground on a $4 million turbine, like, you want to make sure it's in the right spot. So, but once again, you know, a lot of the smaller farmers and stuff, and there's actually a couple of schools. It was kind of crazy because when you get down into that corner of Kansas and stuff, it's very rural. Like, we used to stay at these hotels that had a little lock and key and a little like turn television, and I'm like, man, this is great. And all the young guys with me is like, I don't like this. We got no signal. I'm like, man, look, 2, 4, 5, 8.
Go to video store.
They usually a couple of them had like 2 or 3 different movies or something there. Like, be like Liar or something else like that. Everybody
you get to really know your colleagues.
Yeah. That's actually, I did that for about 2 years. And you know, we were looking at the same 6 guys. Like, I worked in Montana, building some telecom towers up there. And when you're in the middle of nowhere, the first thing you do is, your assessment of, where's the closest hospital. And like, we're 50 miles away. It's just, you're looking at the same guys over and over again, and it's a lifestyle. So I kind of got out of that, but I enjoyed it, learned a lot of project management stuff. Because working out there in the middle of nowhere, you have to make sure you got everything. We were working at Alltech in the Bahamas, and we actually had, because we used to have to lock each nut all the way around, do a,
lockout, tag out?
Not lockout, tag out, where it's tight. My mind's gone blank. But anyways, we didn't have the right size to go to it, so we had to wait like 3 days to have something shipped to us. A lot of logistical stuff. So you have to be prepared before you go out there.
It's easier to send a spare part than it is.
I'm going to say something, but the movement you're making stuff makes me think about a socket and ratchet.
Yeah, when you what am I thinking? When you tighten the bolt and we used to mark them and had to go back through. Crap, why is my brain gone?
Torque
each one. Yeah, we had one that was like this big, but it was, it's been so long ago. It wasn't electric. I think this one was, I don't remember, but we'd set on there and then it would do itself and it would stop, and then we'd mark it. So we didn't actually have to torque it. So, which was kind of cool, because when you're at, I think some of them had 40 bolts and they're that big, you got to do a bunch of them. So you can set one, do the next one, and have 2 or 3 going at a time.
Be more efficient that way.
Yeah, that was, and then working in those damn things. Good Lord. And because once you open that thing, there's no airflow until your partner gets to the top and opens that hatch and you get an airflow. Like, it was hard. It was rough, but I enjoyed it. Sitting on top of a tower. I used to climb towers. It's all 550 feet. So I was sitting on top of the tower one time, and we actually had a crane company come out, and when we would build the telecom towers, we had to build in like 20-foot sections. So when we get to the top, it's like everybody's on a leg, and you're like, table down slowly. You're looking at like 30,000 pounds of steel. And I'm like, whoa, I'm going to get a little wobble up there.
You can't outrun it.
Yeah. And I still wasn't small then either, so I could top up there and get swaying, Lord, I enjoyed it. That was cool.
Really?
Oh, man.
Man, I couldn't do it.
It's my nightmare.
I do not want to be. You jump.
I've got another question.
I'd have to be tied.
I know
off all the
earlier,
time.
before we start recording, you were talking about, different like bases and stuff you've been on, and like, it really wasn't a whole lot of text back then. So is that something some of our viewers, maybe a career they might be interested in getting in? Is there a need for like technicians?
Yeah, well, and literally electrical. That's why I got the school that I chose. They had a hydroelectric program, they had a solar program, then they had wind techs that were just for wind, but I chose electrical engineering because it was broad. Like once you know how things work and things talk to each other, then you have the tools to figure everything else out. Right. As you're being put on this, like it's hell getting old. Like can't remember everything, but as long as I had a teacher who taught me when I was in that school, one of the smartest things ever. He was like, we were doing tracing circuits and stuff. He would just draw one out. And he was like, you have everything in front of you to figure out how to do this. Like, you have more technology in your hand than I've ever had in my entire life, And he was taught the skills how to find those things. So, getting into a broad thing of like electrical engineering instead of being very specific, because, once you get in those like very specific things, then it was just a little harder to navigate to move to something else. But,
it's high risk, high reward, right? Like a neurosurgeon is going to specialize, is going to make a lot of money. But how many people are hiring neurosurgeons? Well,
and I will, yeah, exactly. And I will tell you right now too, I've never been in the military. I've just worked on the bases and stuff, doing stuff. But now I do read a lot, and I was just reading that the U.S. Army is about to cut like 40,000 jobs or something because of recruiting and stuff. But I think they're fixing to do some pivoting because I'm not going to try to get into world things, but because the world we live in now, drones and everything are being utilized a lot more, and a lot more things, technology that way is going. Yeah. So I feel like military drives all of our industrial, everything that we do basically. So getting even into the military and stuff now is not what it was back when, everybody was younger. So having those electrical skills and those hard skills of like working on stuff, I think moving forward now, we might start seeing a lot more jobs open up with just fixing robots and all the stuff that's going on.
Yeah,
so there's I probably would never tell anybody to join the military in the past, but now though it's becoming all video games and stuff. It's kind of crazy. I've been keeping up with the world we live in, and a lot of the drones, a lot of stuff that they're using now is all that stuff's going to be fixed. Yeah. We have to build the stuff. That's why I work in the music industry now, but fixing lights and stuff, I'm like, well, if everything hits the fan, at least I can fix drones for everybody.
Exactly.
They ain't gonna kill me.
Exactly. Well, all that is pretty cool, Seth, and kind of scares me to death. I can't imagine being on top of one of those radio towers and all that, But then you mentioned how you're in the music business now.
Yeah.
So hold that thought. Okay. I'm gonna close this out because I want to talk about that.
All right. That sounds great.
Yeah. Jeff, producer Jay. I was trying to note everybody. There we go. All right, guys. Hey, appreciate you tuning in. Check us out at ProfitDig.com, the world's easiest to use job bidding and costing solution. Like the video, subscribe to the channel. If you have a comment, let us know. Let us know what you want to talk about. We'll see you next time.
See you guys.